And we still got some people coming in here. Okay. So welcome back, everybody. So happy Friday, and I hope that people are doing okay wherever you are. We have been stuck in the house for a week with a 4-month-old puppy. It's been really tough. So it's been intense. So I am hoping that I can see you all in person next week. So let me share my screen and we can talk about some administrative things here. So I want to point out to you, so if you go to the anticipated course schedule, and look at this. So remember, I'm really trying to keep everything in bold on this schedule, right? So like when quizzes are due, et cetera, on track. So we are scheduled to have our first comprehension assessment on Monday, February 9th. So I do 4 in this class because it makes a lot more sense. We're a 50-minute class and it's real detailed information. So it makes sense to do 4 sort of shorter assessments rather than 3 bigger assessments. So the first one is planned for Monday, February 9th. So I wanted to talk about it a little bit. I am going to try to keep that, even though we've had this week and it's been a little bit weird. I'm going to try to keep that on schedule if needed. So I've always had sort of an overflow day. And so that helps us to get some material in there. And if needed, I might move some of this material to after comprehension 1. I would rather keep the comprehension assessment on schedule just because that's when everybody was expecting it to be, rather than try to like shove all the information in there. So I just wanted to talk to you a little bit about it today, and then we'll come back to this next Monday. We've still got a lot of time for you to be thinking about this. But I do want you to start thinking about this. So one of the things I posted under week 3 is I posted a handout on the assessments. This is also in our modules. Let me go to view a student here. And here is a document, just a little bit about how these assessments will work. Okay, so I will zoom this up. So the first thing I want you to know about these assessments is what they will look like. If you took me for biological psychology, the format is fairly similar, but this is a 50-minute versus a 75-minute class. So it's a little bit shorter, a little bit less material. So most of the assessment is going to be done in class, right? During that 50-minute class. So you will come in, I will give you a packet with paper, right, where you can take this assessment. So it's going to be handwritten. You cannot have, unless you have accommodations for this, you cannot have any electronic devices, right? So it is you, a pen and a paper and or a pencil, taking this. You can use a study guide. And so I'm going to talk a little bit about the study guide here in a second. So you can bring in a study guide. And one of the things I want you to know is that I do grade these blind. So when you pass this in, if you had me for biopsych, you're familiar with my methodology of you stapling the piece of paper that has your name on it. So that I can't see who you are. So what this will look like is the in-person part of this. There's going to be a little bit of fill in the blank. So just a couple of these, 5 of these, and this will be worth 5 points out of 50 points. So that really means it's worth 10 points on the entire, right, if it's out of 100. And so these are just like real simple, I know terminology. There are going to be 5 questions that I call very short answer questions. Very short answer questions are literally like a sentence or 2, right? So not an essay, not even a paragraph, but just like showing me that you have some of these basic concepts. So there'll be 5 of those. Each of those is worth 3 points each. And then there are going to be 2 short answer questions. Short answer questions are often paragraphs, but sometimes I'll put them into table format. So you're just kind of like filling in a table. Those are going to be worth 10 points each. So a little bit less material than you're used to if you took me for biopsychology, and hopefully that will work within 50 minutes. And then there will also be an online portion. So the online portion, I'm going to come back and talk about next Monday because I always make it available a week before the assessment. But the online portion, I'm going to ask you to go find some news piece, right? Something that talks about a study that has been done that is related to content that we've talked about. So goal there is to get you to extend, right? Like make a connection and extend the material that we've been talking about. So this online part, I will talk about next Monday. All right, a little about the study guide. So I allow you to use a study guide. I started doing this a couple years ago because I just feel like maybe at this level of you learning, you memorizing all of these things is not the most productive way that you're using your time, right? I really like, I think that you should be demonstrating that you're understanding these concepts, and I don't want you to get hung up on memorization of the information. So I allow you to bring in a study guide. The rules for the study guide is one, it needs to be hard copy. That could be either you're handwriting it or you're typing it and printing it out, but it's not something you're going to have on a tablet. It's not something that you're going to have like on your computer available to you. So I want you to have something physical that you're using while you're taking the assessment. Your study guide cannot be more than 1 page, and that's 1 page front and back. And that's a little bit less than what you're used to if you took me for biopsych or methods. I know I allowed you 3 pages for that. One thing is this is a shorter test and a shorter assessment, but I also noticed that in past, the study guides that people are making are often just a page. And I think it forces you to be a little bit more focused and a little bit more intentional with the material that you put on. So I've reduced that requirement. I really discourage you from including big blocks of text. So people get very hung up on this full sentence, right? Requirement here. I It's okay. Like I'm not going to read through every single person's study guide like point by point. But I'm really trying to get you to paraphrase, to bullet point, to put things in your own words because that's what's going to help you to process this. So the whole point of making the study guide is that it helps you to better understand the material. It's not necessarily so you have it when you're taking the assessment. It's you thinking about how to organize and how to do all this is going to help you to better understand this information. You can include images, but you have to make the image. So you can't just like screenshot pictures from the Prezi and put them on the study guide because then that starts to blur into your screenshotting the entire slide with all the content, right? Like again, the idea is that you're thinking about how to put this into a format that you can use best. So just screenshotting a picture is not going to be a good way to do that. You can work with other people making the study guide, but you each have to have your own, right? So you should not say like, oh, I'll do this part and you do this part and then we'll combine them. Because again, like using somebody else's study guide, it's not just about having the material when you're taking the assessment, it's about you putting it into a format, right? Like you going through that process. And then I will collect your study guide after the assessment. I will pass it back to you so you have it. But I do want to just see it. I want to have it as a reference as I'm grading, et cetera. I just like to have them in case I need to see it. So some things that I suggest, and this is one of the reasons I'm talking about this today, right? Even though your first assessment is not until the 9th, start early, right? Start thinking about how you're going to organize this. So we're hopefully today gonna finish up on talking about pharmacokinetics, right? So this is a perfect time to take a little bit of time, process, and start to make your study guide. Really think about organization, right? Don't fall into this trap of, oh, I'm going to have this study guide. I don't need to really think about like how I'm organizing, or I don't really need to study beforehand. Think about how you are going to organize that information. You have 50 minutes. That is very short. And so you're going to have to find that information very quickly. Use the Prezis, right? So the Prezis are really key in terms of guiding you in the content. So when you think about like what should I put on my study guide? The Prezis, anything in the Prezi is going to be fair game. And remember, sometimes there's things in the Prezi that aren't in the text, and I will still hold you responsible for those things. So I would really start with the Prezis. Things that we covered for a long time are going to be more highly represented, probably, right? So if we did like an activity, or if there's a handout, things that there's only one slide on, maybe that's just going to be like a fill in the blank, right? So like use the Prezis as a guide. The things that overlap in the text with what we talked about in the Prezi could be important, right? Like those are the things in the text that you really want to focus on. If there are things in the text that you never heard us talk about, it's not going to be on the assessment, right? This is way too detailed, way too much information for me to hold you responsible for that. The reading quizzes. So those are good guides as well, right? Just it doesn't necessarily mean that it's going to be on the assessment, but it's a good guide as to what I think is important. And then clearly the notes that you take in class, right? Like those can be very helpful for providing context, right? Sometimes I'm like, hey, something like people often get this confused. Don't get this confused. Use that as something that can help you go onto your study guide. You really should not be copying or pasting or screenshotting anything. If you're using exact words, right? Like if I'm asking you to explain something and you're just copying from what was on the Prezi, you're not going to get full credit because I'm upping the ante, right? Like I'm allowing you to use notes. So I'm really asking that you show me that you understand this. And remember that I'm focusing on comprehension. It's not just that you know the words, it's that you can explain things. So you still have to study, right? Don't fall into the trap of, oh, I'm just going to have the study guide and that can, like, I'll just have the information there. If you don't understand it before you come in, you are not going to have the time to be able to answer these questions and you're not going to be able to finish the assessment in the 50 minutes given. So you really have to study. Honestly, you should barely be using your study guide when you come in, right? It should just be sort of a security blanket. If you have prepared well, you won't need to use it at all. If you have questions, come talk to me about those questions. I'm happy to give you advice or feedback and help you study. The one thing is, I'm not going to look at your study guide and be like, oh, you should put this on there, or you're missing this, right? Like that's your responsibility. I am happy to answer questions, right, and talk about it, but I'm not going to help to like proofread your study guide. All right, so I'm going to stop there for a second. What questions do we have about that first assessment? Again, knowing next Monday we'll come back, we'll talk about the online part. But what do we want to ask now? Feeling good so far. Okay. I know a lot of you are familiar with this because you've had me before. The big difference with this one is just only a page, but some of you have not had me before. So if you're feeling unclear about what I'm expecting here, then that is fine. Somebody asked, will the questions from the review assessment be included? Not the one that you did, right? Not the basic review assessment. What will be included, however, and so this is a good segue for me to show you, is under, right, the materials for comprehension one. We have the Prezis we've gone over so far, and I did post a page that I told you I would post about the asynchronous information for the advanced neuron review. So this is information that normally I take a lecture to cover. It's usually not a great lecture because it's fairly boring. It's a little bit awkwardly timed. So this is something that many of you already know. And so if you're going through and you're looking and you're like, oh, ionotropic versus metabotropic system, or actually I meant to write receptors there. I'll have to change that. I like have covered that 3 times. You don't have to watch this video, right? But you will be held responsible for the content. So this is something that I'm walking you through. I will tell you, I told you I've been in the house for a week with a 4-month-old puppy. It is intense. And I am struggling to find time to like take these asynchronous lectures in a time where it's not super noisy and just finding the time. So I have a couple more of these that I just need to post. I'm going to do that by the end of today. But it is your responsibility to come up and to make sure that you're feeling comfortable. This is the reading. I'm reminding you about the quiz that you took on this, and then these videos. So next week is an excellent time for you to come in and to be like, I'm still not understanding the point you're making about like what a metabotropic receptor is, and we can talk about that. All right. Other questions?
So I know you don't want us to use like the Prezi slide itself, but I remember from when we did it for methods, you were okay if we use like the pictures that you use, not the entire slide, but like in the pictures. Is
So
that a yes
I
or a no?
I have changed that since you took methods. So at this point, I don't even want people to screenshot the pictures. Like I want you to go through the process. If you're gonna like have a neuron, right, draw your little presynaptic neuron. It's gonna be so much better for processing the information. So yeah, so that is a change since you took methods with me.
Also, I remember you used to give us like the guideline of like which topics for sure were there. Are we doing that or no?
I'm not, yeah, that's a method specific thing. Just because methods, it's so hard to separate out like the project material from the like the content material. But in this class, it's all content material, right? So it's like anything that we have covered is fair game, right? So it's less needed for me to say like, oh, this was for the project and this is what's going to be on the assessment. So yeah, I would really use the Prezi as a guide for what needs to be on there.
Okay.
Other questions? Okay, so you know you can come back to me if you have questions about this. Come to office hours, etc., and we can talk about it. Okay, so let me go back to. Actually, I'll do it through here. What we were talking about. Okay, so we left off talking a little bit about depot binding last class, and I was making the argument that what we want is for this ligand or this ligand to bind to an active receptor and cause a change in the cell, right? So that's that review assessment that you did. But sometimes what happens, and those are the ligand gated receptor channels, sometimes what happens is those drugs, so we're talking specifically about drugs right now, bind to inactive sites, right? They bind to fats, or they bind to protein, or they bind to muscle. So when there's depot binding and they're binding to these inactive sites and they're not creating any type of cellular change, then that means that it's changing the bioavailability. So remind me if you can, if you're willing, what do we mean? Like, in what ways might this change the bioavailability? In what ways is this going to impact how available that drug is?
If the drug is bound, it's unable to
It's unable to what? Sorry.
be free to bind receptors.
Right. So one of the things is this going to reduce bioavailability, at least temporarily, right? Because if the drug binds to something like this, it can't absorb into the bloodstream, right? And it can't get into the brain to have an effect. So that's going to reduce the bioavailability. What else is this going to do? What other consequence do we have?
I'm sort of just reading off my notes based off of the next point, but it can't be metabolized while it's bound.
Yeah, so while it's bound, we can't clear it. And clearing is something that we're going to talk about today. I played the strokes, right? Metabolism, because we're going to talk a little bit about metabolizing drugs. But yeah, while it's bound, it can't be metabolized, which means it's staying in your body. And we talked about the fact that that could recirculate later on, right? Like THC can bind to fat, and then at some point can be released and can then be circulated in the body. And then this was the complex one, right? That I know it's kind of counterintuitive because we said here that depot binding means that it's reducing bioavailability of the drug. But there are times, like if you're taking two drugs simultaneously, where it might increase the bioavailability of one of the drugs. And remember, that's because if I take any one drug on its own, right, it might depot bind to these, in this case, it's these plasma proteins. And then a second drug also might depot bind to plasma proteins. But if I take them together, there's not enough plasma proteins for both of them to depot bind to. And so one of them is going to lose the competition. And it means that it's going to be more available than it would have been if you took it on its own. And so an example, this is not a psychoactive example. There's actually like not a ton of psychoactive examples that we have. But the interaction between a drug called warfarin, which is an anticoagulant, so it's just a blood thinner that people take to reduce risk of stroke or heart attack, and aspirin. So warfarin is really highly bound and binds to these plasma proteins. But if you take aspirin at the same time, aspirin's going to displace that. And that means that the warfarin is going to be more bioavailable. And I use this example just because there is this video. So I'm going to show you this video. It's not like a YouTube video. It's a sort of one of these educational videos.
Drugs may compete for binding with plasma proteins, leading to interactions. This is significant for highly bound drugs such as the anticoagulant warfarin, since even a small change in binding will greatly affect the amount of free drug. Such an effect is produced by the concurrent administration of aspirin, which displaces warfarin and increases the amount of free anticoagulant.
Okay, so that's just a good visual of that happening. And so this is just what's happening, right? Because both bind to the same plasma protein, aspirin will displace the warfarin, makes the warfarin more bioavailable, and that's really dangerous because then you have a really high risk of having bleeding that can be uncontrollable, right? Because it is a blood thinner. So that's an example of a drug interaction. Not all drug interactions come from competition for depot binding sites, but it's one example of what could happen. All right, ask me questions about that or ask me for clarification about that. We're feeling good. Depot binding. Okay, I think a psychoactive example I found is valproic acid, which is a anti-seizure medication. Also, it's Depakote, used for bipolar disorder often or states of mania. That can interact with benzodiazepines in the same way, and it can make benzodiazepines more bioavailable and thus have a higher sedative effect than if you had not taken them with the valproic acid. Okay. And so depot binding, this is something when you're looking at your own drugs, right, and doing research on your own drugs, because you're going to have this project that you're doing. Depot binding, often you can't find a lot of information about. And so it's something I like to cover it because this is like you're supposed to be learning the basics of psychopharm. But it's not going to be like super, super relevant for most of our discussion. But I wanted to show you this is an example of article that just talks about the pharmacokinetics of caffeine. And they talk a little bit here about how caffeine binds reversibly to plasma proteins, and protein-bound caffeine accounts for 10 to 30%. They're talking about depot binding there, right? So they're saying that when you take caffeine, it will bind to some plasma proteins. A little bit of it will, but just temporarily, right? That's reversible, and at some point that will be released, and that will be circulated through the system. Okay. Questions? I have absolutely no visual feedback from any of you of how you're receiving this. So just like if you need me to talk about something, let me know. Okay. All right, so let's move on to talk about metabolism. That's the big thing for today. And so your book calls this biotransformation. Biotransformation, right, is really just transforming the drug. And when you talk about like drug metabolism, you could be talking about a lot of different types of things. We are going to focus on how the liver turns the drug into something that we can excrete. So when you read this, the book talks about the difference between phase 1 and phase 2 metabolism. We do not need to know that. So you do not need to know about the oxidation. You do not need to know about anything. We really just want to go from the state of the drug in an active state that can have an effect on these target sites, and how we turn that into inactive metabolites that we can then get out of the body, right? Like how do we clear the drug from the body? So I'm going to show you a video. Again, this is not a YouTube. This is like one of these educational videos. It's made for nurses. Very dry, not super interesting. But again, I put it here just to give you some context and some more information so that you can understand this better.
Drug metabolism. The life of a drug. A drug first goes through absorption, which is the site of administration to the blood. Then it goes through distribution, which is the blood, to the site of action or the target organ. After that, it goes through metabolism, which is the biotransformation of a drug. Lastly, it goes through excretion, which is removal of a drug from the body. We're going to focus on drug metabolism, which is the enzymatic conversion of one chemical compound or drug to another. Primarily, it takes place in the liver, but can occur in other areas of the body. Medications taken orally follow the same digestive track as your food. It makes its way to the primary site of metabolism, which is the liver. Enzymes in the liver can activate drugs, inactivate drugs, make drugs more effective, increase or decrease drug toxicity, which is too much of a drug in the body, or convert drugs to a different form so that the kidneys can easily excrete. The P450 system breaks down drugs into smaller molecules. They are a group of 12 closely related enzyme families in the liver. CYP1, CYP2, and CYP3 all metabolize drugs, and each metabolizes only certain drugs. Metabolic processes convert the drug into a more water-soluble form for the kidneys. The drug is then filtered through the kidneys to be excreted out of the body in urine. Factors that can affect drug metabolism are disease, age, genetics, nutrition status, other drugs and alcohol, and environmental. Why is metabolism important to a nurse?
Okay, so we don't need to talk about why it is important to a nurse, although hopefully that's fairly obvious, right? Why a nurse would need to understand this. So again, in this video, they're talking about the main thing that we really care about for metabolism is how we are turning the drug. And again, most of that happens in the liver, but we will see some of that starts to happen in the stomach for some drugs, turns that into something that we can excrete. But there are other things that can happen. So when you're doing research on your own drugs, some of you have something called a prodrug, which is you take the drug and the drug is inactive. It's not in a form that it can bind to an active target site, but when you metabolize it, you actually put it into a form where you can do that, right? So metabolism, there's a lot of different factors and it's very complex, but the big thing we care about right now is excreting the drug. Okay, so again, primary thing that we're going to talk about is the liver. And then in this video, they mention the cytochrome P450 enzyme. So we call this the CYP450 family, and you will hear this a lot. This is a family of enzymes. There are many, many different types of enzymes within this family that are responsible for metabolizing, especially psychoactive drugs, right? We just have a lot of similarities in these families and in these enzymes that metabolize these psychoactive drugs. All right, so questions about the basic terminology.
I have just one basic question. It's very basic. How do we know which drug will go to? I mean, I know that when that drug goes when a person takes a drug orally, it goes through the digestive system. It goes through the stomach. But how do we know which drug will go through metabolism in the stomach or will go through metabolism in the liver?
Because people have studied it, because people have done clinical trials where they have given drugs and they have studied, right, either in human models or non-human models, how much of that drug is bioavailable. We can measure things like whether the drug binds to certain receptors. We can measure metabolite excretion to see how much of that drug is being metabolized. So people have done like that article that I just showed you about the pharmacology of caffeine, right? That's a study or a review of studies that people have done to understand understand all of these different pharmacokinetic factors that are influencing the bioavailability.
Okay, thank you.
Okay. So, somebody in the last, I think it was Callan in the last meeting, had asked about half-lives and had asked about the things that influence half-life. And we haven't talked about half-life yet, but we need to now. So when we put the drug in our system, eventually we need to get the drug out of our system, right? The drug is not going to exist in our system forever. So drug clearance is about the rate that we are clearing the drug from our body, from our blood. And so what these images are showing is just, this is a representation of, I have taken a drug, it has been absorbed into the system. And so I like that kind of boring nurse video because they go over, right? Like they review, it's absorbed and then it's distributed. So like we have the drug circulating everywhere through our body. And at some point, right, depending on how we've put the drug in and et cetera, that drug is going through our liver and our liver is starting to metabolize and starting to clear it into something that we can excrete. And so here we start with a high concentration of the drug. I know you can't really tell, but here you have a lower concentration of the drug because the liver is metabolizing it. And now we've removed a lot of that drug, right? We have a lot lower concentration of the drug. And as we start to get rid of the drug, clearly the drug is going to have less and less effect. Okay. So the rate and how we do that differs depending on the drug. Most of the drugs that we're going to talk about are metabolized via what we call first order kinetics. And kinetics is just a fancy word for the reaction, right? The reaction of this chemical. One drug, alcohol, is going to be metabolized via zero order kinetics. And so I used to talk about both of them here, but especially because we're pressured for time, I'm going to save zero order kinetics for when we actually talk about alcohol. You do not need to know about it right now, and it's probably going to confuse you. And so I put here, I want to keep it just because I want to keep my Prezi like in a shape that I could talk about it in future years. But I put very explicitly, like, don't study for this for exam one, right? We're going to talk about this when we talk about alcohol. You do not need to know this right now. What you do need to know is first order kinetics. And so first order kinetics is describing the rate of our drug clearance and saying that the rate is really dependent on how much drug is in the blood. So what this figure is showing you here is it's showing you the amount of drug that is measured in the plasma, right? And so we're starting with 100. So we're starting with like, that's the maximum capacity of drug within your system. And then we're looking at how that amount is reduced over time. And so what we do is with first order kinetics, just the rate that it is removed, is we consider what is the length of time that it takes for 50% of the drug to be removed. And the length of time that it takes for 50% of the drug to be removed is considered a half-life. And so this half-life is going to be different depending on the drug. So for every drug that is metabolized via first order kinetics, this chart is always going to look the same, right? So we are saying every drug is basically eliminated from the body, basically cleared from the body after 6 half-lives. Yes, you start to like exponentially go down, right? There's always going to be this little bit, but functionally, by the end of 6 half-lives, right, you will have cleared the entire drug. So what is different for each drug is the amount of time represented by this half-life. And so think about it at time 0, you have 100% of the drug in your blood at time 1, right? Whatever that length of time is, that's how long it has taken to remove half of the drug. So for THC, the half-life is about 24 hours. So remember I told you THC, very lipid soluble, very fatty, right? It likes to bind in fat. So it takes a long time. That's a very long half-life to eliminate the drug. So you start with 100% in your system. It takes about 24 hours. And there's going to be things that affect this, but it's going to take about 24 hours just to eliminate 50% of the drugs. So how long then would it take you to get all of the THC out of your system, theoretically? If one half-life is 24 hours,
And you said it takes 6 half-lives to get a drug
Six-
completely out of your system?
about 6 half-lives. Yep.
So that would be 6 days?
Yep, I would say about a week, right? By the time you're like, you go from here to here. So 24 hours, one day, 2, 3, 4, 5, 6, 7, right? So yeah, about a week to clear all of the THC out of your system. And that's a long time for a drug. And so that's how you think about using the half-life, right? And think about looking at this chart. As an example, right, like bringing this back to caffeine. So caffeine is metabolized primarily by an enzyme called CYP1A2. And that is part of the cytochrome P450 family. So we talked about that family of enzymes. So this one enzyme is part of that family, and that's why it's called C1P, and that's the thing that is helping to metabolize caffeine. So caffeine's half-life is very different than THC. And again, these are going to vary, right? So if you look these up, they're going to be slightly different. But usually we say the average half-life of caffeine is about 4 hours. So THC, 24 hours, right? Caffeine is only about 4 hours. So we start with 100%. And then after 4 hours, we have cleared about 50% of the caffeine from our system. After another 4 hours, we have cleared another 50%, right? So now we're down to 25%, etc. All right. So after 8 hours, right, how much caffeine is still in your system?
Is it going to be 25%?
Going to be 25%. Yep, because you're starting. And so remember, it's no, don't be like 4 hours, 8 hours. And this is where like taking notes, right? And having the context helps. It's going to be time 0. After 4 hours, you're down to 50%. After 8 hours, you're down to 25%, right? After 12 hours, right, you're down to like 12 and a half. All right. So questions on how we interpret these half-lives, questions on what this figure is telling us.
That depends on the drug, right?
It depends on the drug, yes. So this figure will always look the same, right? This figure, the exponential clearance of the drug is always going to look the same. The thing that differs is how long between 100% and 50%, right? For THC, it's 24 hours. For caffeine, it's 4, and that's very different.
Okay, thank you.
Okay. So, Callan, I think, and sorry if I'm misattributing this to Callan, but I was pretty sure it's Callan, had asked the question about like, well, what, I can't quite remember, but the half-lives came up, right? And like, what could influence that? And if you all are watching The Pit, which I know some of you are, great show, this came up in the episode, I think last week, where some drug, they were like, oh, that's a very fast half-life, right? So like understanding what this means, this is like clearly relevant in a medical context. So there are things that can influence what the half-life is, right? So like what I'm showing you here when we talk about first order kinetics, right? And we talk about like THC, that's on average. That's we're taking like a whole big group of people and saying on average, how long does it take you to clear? But it might take me longer or it might take me shorter because of me, right? And who I am. So we want to talk a little bit about some factors that can influence what the half-life is in individual people. Okay. And there are 4 factors that your book talks about. And so I want to point out I gotta exit out of here. On Canvas for this page, or it's under modules as well, I put a handout called metabolic examples. And so what I usually do in class is I will pass out this handout, right? It just has 4 different examples and you're supposed to match them to the different words. And I will ask you to, like, I'll give you cards and I'll be like, twos, who are you, etc. I'm just gonna walk you through this and have you have access to this, just because I think it's gonna be a little bit hard to do that on Zoom, and I want to make sure that we move through it efficiently. But each of these is mainly supposed to help you in terms of thinking about these factors. So the first one, I'm actually going to start with 2. This is the idea that people who smoke, because they smoke, the cigarette smoke actually makes you have more of that CYP1A2 enzyme. And that is an enzyme that is responsible for metabolizing caffeine. So if you smoke, then you are actually going to be more efficient at metabolizing caffeine. And so let me go back to the Prezi here. This is something called enzyme induction. So enzyme induction is anytime you are doing something to increase the amount of enzymes that metabolize a drug. And so you do not need to know, right, like how we make an enzyme. You don't need to know about the substrate or the inducer, right, for the purpose of this class. But what you do need to know is sometimes, right, the rate that we make an enzyme is influenced, right, by certain things that we do. So if we take a drug, and it might be the own drug, like alcohol will induce its own enzymes, right? And that's a tolerance thing that we'll talk about. But if you take a drug and that makes you make more of an enzyme, then you're going to have more of that enzyme to clear the another drug, and you're going to reduce the bioavailability of that, right? You're going to reduce that drug effect. And so this is just a visual of the example that I gave. And so we know this. This is not nicotine. It's not tobacco itself. It is literally a component of the actual cigarette smoke. If you smoke like traditional nicotine cigarettes, that is increasing a whole bunch of enzymes that you make. And one of them is that CYP1A2. So people who smoke cigarettes are better at metabolizing caffeine, which means you are reducing the bioavailability. They are going to have a shorter half-life. They are going to be much more efficient at clearing caffeine out of their system.
So, I have just a quick question.
Yep.
So does that mean that smokers, people who smoke a lot, does that mean that if they consumed a lot of caffeine, that means that that caffeine is not going to be it's not going to have much influence like other people who are not smoking, who are not smokers?
They are less sensitive to caffeine. It does not affect them in the same way.
Oh, okay, got it.
Yeah. What other questions? Okay. So something else, so this is a separate factor, right, that can happen is as opposed to making the enzyme more and going through enzyme induction, you can also do things that will inhibit the enzymes responsible for metabolizing a drug. So you could have enzyme inhibition. So if you're doing something to inhibit the enzyme, that is going to make the drug more bioavailable. It's going to increase the effect because now you've made it so the drug can't do its job. Sorry. In this figure here, way more complicated than you need to know, right? You do not need to know the specifics of this. Again, you do not need to know about the substrate and the inhibitor, any of these things. I just wanted to put a visual to sort of supplement this. So looking at these examples here, so we've already taken out 2. So which of these might be a good example of enzyme inhibition?
Four.
Yeah. So and it's using right, did I use the word inhibit? Oh no, I was care. Oh yeah, no, I did, right? Oral contraceptives inhibit. It's really hard to talk about examples of these without talking about inhibition. But yeah, oral contraceptives we know can inhibit that enzyme CYP1A2. And so this is just an empirical article on that. And so that means that people who take oral contraceptives may actually be more sensitive to caffeine, right? Because they have taken something that has made that enzyme less effective. So their half-life is going to be longer than average. Questions about that? Okay. The next one is drug competition, which is very similar to what we talked about, where we're talking about drugs competing for depot binding sites. But this time it's just that drugs are competing for the enzyme to metabolize them. So this again can lead to a drug interaction. If you are taking 2 drugs and both of them need the same enzyme to clear the drug, one of them's going to lose, right? One of them's going to hang out in your system longer because it just has to wait for that enzyme to be available. So I couldn't find one specifically with caffeine, but this is one with cannabinoids. So if you are taking cannabinoids with another drug, right, and they both need the same enzyme to be metabolized, then the loser is going to not be able to be metabolized, and that means it's going to be in your system much longer, which is going to increase bioavailability. And so this one is a little bit confusing. I'm trying to find ones where caffeine, right, is part of this. And there's nothing that makes caffeine more bioavailable, but I did find one where if you're taking melatonin, which you can take, right, like you can take supplements to change your melatonin, and caffeine together, it can actually increase the bioavailability of melatonin, right? Because they compete for the same things, and caffeine wins and melatonin loses, right? So melatonin, it takes longer to metabolize it, and it stays in the system. So this is not one where caffeine is more bioavailable, but the interaction between caffeine and melatonin makes the melatonin more bioavailable. Questions about that? And then the last one, this is the easiest one, is just this idea. So this is one where we're looking at ancestry, right? So things that might be linked to genetics, and just this idea that there are individual differences, right? And especially like genetic individual differences that can, sorry, I'm having a hard time moving my stuff on my screen. That can influence, oh, this is an empirical article about the melatonin and the drug competition. That can change how much we metabolize, right? So like how old we are can change our metabolism. Adults have a harder time metabolizing alcohol. There are often sex differences or sex differences probably. These have a lot of things that we're not going to talk about, right? Like organ transplant, etc. But there's just things about us, right? Some of us just make more of the enzymes, just like genetically, we make more of the enzymes. And so I posted this article here, not really an article, more like a news piece here, just talking about some genetic variations. This is a great extra credit. I'm not going to hold you accountable for the different variations in here, but some of you have already asked this question, right? About like why, like why might caffeine not affect me? And these are some things that explain why some people don't enjoy caffeine all that much and others really do, right? Or some people it really affects them and others it doesn't. So that is something else that can influence your half-life and influence the rate of clearance. Okay. So we are pretty much through this. So excretion is like one slide that we'll cover on Monday. So I know we're at the end here. Again, I really appreciate you all coming and joining me in this fashion. I really, really, really need you to like review this and come talk to me if you have questions. I know it's just very difficult for me to gauge, right? Like what people's faces look like, how people are processing this, whether this is making sense. So I really need you to like be accountable for your own learning and let me know what we need to review. When we come back, and I'm hoping that I can see you in person next Monday, we're going to talk a little bit about pharmacodynamics, and I will just see like how far we get, and wherever we get on Friday, that's just what the assessment will cover, and we'll do the rest after. All right. I know it's a little bit past, so log off if you need to log off. If you want to hang around, ask me anything, right? Clarify anything. I will stick around to do that. All right, you all. Thank you so much. I appreciate. Oh, sorry, people have been chatting and I can't see. Okay. Thank you so much, and I hope I see you on Monday. Bye. Awkward wave.
Thank you, Dr. Stebbins.
Thank you. Have a nice weekend.
Dr. Stebbins, I do have like a quick question.
Mhm.
So for like the half-lives, will we be asked to like do a little bit of math for the half-lives? Uh,
You might. Yeah, you might. Simple math, right? So like it's all like how many hours or what percent. So just understanding that interaction, right, of the timing of the 50% or the clearance of the 50%.
so like yeah, so with the drug interaction, you'll probably just like give us the concentration and then like we'll have to do like if it's 50%, it's times 0.5 or like if it's 25% times 0.25 to get like the hours it or like
Yeah,
the hours.
it will be very similar to what I asked in the Prezi. Like those two are examples of the type of thing that I might ask.
Okay,
Yeah, to know
thank
that
you.
you know how to use that figure. Yep.
Got you. Thank you so much.
Yep. Have a nice weekend.
You too.
Anybody else have questions? I know there's 3 people up here. I'm not sure if that means you're hanging around for me or
I just have a quick
yeah.
question regarding the announcement
Mhm.
that you wrote about ODR. What is ODR? Is
Oh, those
ODR?
are for people who have accommodations,
Oh, okay.
who
Thank you.
have like extended time or have to take the test in a separate room.
I just have a quick question
Mhm.
regarding the assessment. So generally, do you think it's doable to complete the assessment within 50 minutes?
It should be. So I think you came in a little bit late. I actually spent like the first 10 minutes or so talking about the assessment. So I would go up and look at that paper, the handout that I posted that reviews like what it's going to be about, what's going to be on it. Um, it's designed to be done in 50 minutes. I mean, some students will struggle, right? Like 50 minutes is not a long amount of time, but I design it for most people to be done in 50 minutes. But what I told them is you really got to come in prepared. Like you got to like know your stuff so that you're not sitting and struggling and thinking about stuff. You just got to come in and like answer the questions. So yeah, most people do fine. I always have a few people who
Struggle.
I have to take the assessment out of their hands at the end.
Oh, okay. Got it. Okay. Thank you so much.
Okay. Have a nice weekend.
You too. Thanks.
Yep. Are you there, Jennifer? Do you need me or? Okay, I'm just gonna assume that you don't know that class is over and you're just still logged in. So I'm gonna leave.